Okay, so this was brought to my attention, pre-lab question number 4. I figured a bunch of us are going to come in on Friday and say I didn't know how to do this. This was very similar to actually the same type of problem in our homework number 42, but I collected that. So I'm just going to refresh your memory. So they say for number 4 we need to determine how much the volumes of each. So we have a 0.1 molar acetic acid, and we also have a 0.1 molar sodium acetate, right? And we need to make combined together, we need them to add up to a 10 milliliter solution, and they're going to give us different pHs, and we need to figure out how much of each we need. If we need 10 mils. So I'm going to do letter A, and then you guys are on your own for B and C. All right, so for A, for all of them, we're going to use the Henderson-Hasselbalch. So pH equals pKa plus the log of our base over our acid, which is our acetate ion over our acid. So I'm just going to write it like this, though. Base over acid. Okay, so looking at that, the A asks for a pH of 3.7, so I want my pH to be 3.7. I think they tell you the pKa is 4.7, so we have this plus log. Now I'm going to abbreviate B over A to represent acid and base. Okay, so we're going to solve for that ratio, and when we do so, right, we get -1 equals log of B over A, therefore, 10 to the negative. So we end up with 0.10 equals B over A. All right? Now remember, this is less than 1, therefore we know the concentration of A must be greater than B. But since the concentrations we know are the same, they're both 0.1 molar, right? We know also that, so the volume of A must be bigger than B, okay? So there's lots of different ways you can do this. So if you remember and you want to do it your way, that's completely fine. You can use the substitution method, right? We can, because we know that A plus B, we know that it needs to equal 10 milliliters. But remember, concentrations and molarity are in liters, so really A plus B must equal 0.001 liters, right? This is the one that we need to focus on because we're dealing with concentration. So, right, knowing this, you can substitute, we can, kind of substitute and figure out what we have. So we know that A plus B must equal 0.001 liters. So I'm going to use this equation and substitute it in here, okay? And it doesn't matter which way you want to do, but I'm going to solve for B because I want to know my A because I know it's larger. So I'm going to go, it's kind of crooked, sorry. So we're going to go, we know B equals 0.10 times A, right? If I multiply both sides by A, okay? So now I can take this and I can substitute it in my equation. So I have A plus 0.10A equals 0.001 liters, right? So really on the left side we have 1.10A equals 0.001 liters. Divide by 1.1. Okay, and when you do that, sorry, doing out my 0.001 divided by 1.1, we get A equals 0.1291, okay? And important on this, right, remember we used liters, okay, so we were trying to find how much of each, so this is in liters, but right, we're going to be dealing with in our lab with mils, so I'm immediately going to get it back into mils, so I'm going to times it by 1,000. And we are going to get sorry, this should be 0.01. It's going to throw us off. Sorry, 0.01. Okay. So really, we get 0.0091. Right? And then we're going to end up with 9.1 milliliters. Okay? And we know if our solution needs to add up to 10 mils, then 10 minus our 9.1 is going to give us 0.9 mils of our base, and our base was the sodium acetate, right? Because of that sodium acetate ion. So we need 0.9 mils of sodium acetate and 9.1 mils of our acetic acid. All right, so those are the steps you're going to follow to do B and C.